Joining us, hands-on healthcare machine learning. I'm Levi.
And I'm Mike.
This is Mike. It's been, we did this last week. Were you here last week?
No,
we had
last
some
week
churn.
I was out. Yeah, we had some churn.
Going
Taylor
anywhere
was in
fun?
last week. No.
Just working?
Yep. Just wasn't my turn,
glad
I guess.
to have you back.
Yeah, great to be back on the show.
Yeah. So today, we'll get into some exciting stuff, evaluating model performance. I know, I can't wait.
Yep.
Hopefully you're all excited. So just some logistics here before we get started. So we want to encourage you to contribute to the conversation in YouTube. So be sure to log into your YouTube account. And we are going to be showing the screen a little bit, so you may need to adjust your resolution to HD. I'll let you figure out which level of HD. And we also encourage you to join the community at healthcare.ai. Blog posts, get notices as to when new broadcasts are coming up, that sort of thing. And join our Slack channel as well. You can find all those links at healthcare.ai. And let's dive into what we have on the docket. So, mailbag.
Yep, we've got a mailbag this week, and then the main event. And we'll be taking questions and answering them throughout the whole show. So.
Beautiful, beautiful. Okay, so first mailbag question is, how can I progress my career in data science? And we get this question a lot, and it's a good question. People are excited about data science. They want to maybe shift to a new role at a current company, maybe change companies. So have you thought about this, Mike? I mean, I had a couple of responses, but I don't want to bias you or lead this in a particular direction.
Yeah, so, I've always thought there aren't too many degrees in data science, and I guess you start to see, business intelligence and data analytics masters. But I think the thing that people are really looking for when they're evaluating data science candidates is, can you do the work? So the best way to showcase that is to have, exciting, interesting side projects posted on GitHub using the tools you'd use at the job. If you can showcase yourself that, with almost like a portfolio, I think that's a great way to kind of sell yourself.
Portfolio idea, yeah, that's fantastic. And Mike himself recently left academia and made this transition.
Yeah, and I found the portfolio to be pretty helpful for that.
That's a great point. So blog posts and GitHub. And so GitHub can be your own personal projects or even contributing to other folks' work. Either one kind of works in that realm.
Yeah. Just something you can speak to about, your own experience and, why you did what you did and what the choices you made along the way.
Yeah, it's super helpful. And don't be afraid of putting stuff out there that might seem trivial, because other people would want to see those first steps, and it helps you to learn things more in-depthly. Whenever I write something out, it feels like I'm learning it a little bit better than if I didn't write it. Go ahead.
I was going to say, I think the Data Elixir newsletter or the Data Science Weekly newsletter, they have a lot of good examples of kind of analyses people have done in their spare time.
Yeah, fantastic. Google Data Elixir. That's amazing. One other thing I had mentioned, so somebody emailed us and said, hey, how do I get into data science? And so I emailed a couple of things. And one thing I said that has helped me is to become known as the machine learning person at your work. So maybe your company's not doing machine learning yet, and maybe they should be. So be the person that knows, in the context of your current business, how machine learning could help, and be able to explain it clearly to executives and others. And soon you'll be known as that person, the ML girl or guy that is the go-to whenever questions arise about machine learning. And that will help you transition eventually in your current company, or give you enough projects that you can move to a different company and do data science, if that's your goal. Great questions.
So we did have a question in the chat about our MOOCs and Kaggle contests equivalent to that, and I would say they are a good piece of that portfolio, but I think having something on GitHub that you've conceptualized yourself and done the analysis is really important, because a lot of these data science jobs are not, they're not going to be, here's a data set and a problem, we want you to solve it. It's going to be more like, here's a problem, can you help? And so they're more open-ended. And that's kind of the downside to the Kaggle competition. There's a lot of structure to it, but I think both of them can be useful tools together.
For sure. So it's super helpful to find a use case and see, like, okay, well, how might machine learning apply here? Because then you're dealing with messy data, and you have to kind
Yeah.
of sort out the real world implications and logistics that aren't always so easy.
And kind of picking the use case is half the battle, you know.
Yeah,
You
yeah.
have to find a use case that's interesting, and the Kaggle competition takes that out of the mix.
Yeah, maybe it kind of helps you determine like what machine learning can do as an initial step, and then from there figure out how to apply it to your business or others. Great questions.
Yeah.
So, second question today was, what version of R is required for healthcare.ai? Fantastic question. And so, just for those who don't follow the R community very well, it feels like quarterly, it's fairly frequent that the base R version is updated. And great question. So, we actually need version 3.2.3, which came out, feels like maybe last year in the spring or summer. So, they're up to actually 4.0 just barely came out. And that is noted in the documentation in the description file if you go ahead and clone the repo or download our code. But 3.2.3 is the answer there, so any new version is great. If you're able to update, that's fantastic. You shouldn't see any problems. But great questions. Keep them coming. And in the chat window especially, we love to see what you're wondering as the discussion flows. We want to be able to contribute and learn from you since this is a two-way discussion. And also in the Slack channel for afterwards, so after the broadcast, how can we help with your projects? Where are you getting stuck? What kind of things are you working on? We want to be able to work together and learn from you so that we're not just working in silos separately.
And just for the community's benefit, 3.2.3 is named Wooden Christmas Tree.
Oh, Wooden Christmas Tree. That
Yeah,
was
so you have
one
to
of
be
my
more
favorites.
recent than Wooden Christmas Tree. And, Another Canoe, which is 3.3.3, that'll work.
Oh, love Other Canoe.
That's the one I'm on. Or Use Stupid Darkness is 3.4.
Oh, that's
Yeah.
kind of random.
Where do you think they come up with the names?
I don't know.
Yeah.
Pointing in a dictionary, I guess.
When we release a new healthcare AI, are we going to give it a name like this?
We might need to get names. That's true. It seems pretty common out there.
Speaking of which, we are going to be releasing a new version fairly soon. Hopefully,
That's true.
Hopefully in the next couple days, and it'll have a great functionality on feature availability profiling and generating AUCs.
Yeah.
And what else is in
Glad
there?
you brought that up. So it doesn't tie you into SQL Server, so that's one thing we've gotten. So a lot of people don't use SQL Server in their personal work. They want to work with CSV files. And so in this new version that we'll release, 1.12 it will be in the next couple of days, you'll actually be able to work both pulling from and pushing predictions to CSV files or JSON files or what have you.
And we'll come up with a catchy name for it too, so it doesn't have to be 1.0.
Yeah, exactly. I saw an Ubuntu release the other day that was Precise Pangolin. I like
Yeah.
the ring of that. Alliteration is good.
Well, we can't steal that though.
No, something similar perhaps.
All right. Well,
Okay.
enough
That's
chatter,
a long
Levi.
mailbag, sorry.
Let's get into the main event here.
Okay, so what are we talking about today?
So today we are talking about performance metrics and how you evaluate machine learning models. And so we'll get into that. We'll talk about classification and regression problems, and then kind of how do you monitor over time, because all these things you got to consider all of them. So first one, let's start with classification. So classification problems, everybody remembers, I hope, that they are, you're predicting a probability between 0 and 1 with the idea of giving a binary outcome, yes or no. And so, the simplest way to evaluate a classification problem is accuracy, which is just how many did you get right, how many did you get wrong. And that has a few problems, with the most common one being, let's think about trying to find a rare disease. And so if we built a machine learning model that was just always predicted that the patient didn't have the disease, if that disease is rare enough, accuracy is going to be pretty high. So, maybe if the prevalence of the disease is 1%, you always say no, your disease is, or your accuracy is 99%. That's pretty good.
Pretty good, pretty deceptive.
Yeah, it's pretty deceptive. That's a great way to yeah, it totally is, because you're not really, that's a great accuracy, a high performance metric, but that's the wrong performance metric, because it's not telling you anything about the model, and your model is terrible because it never identifies any of the sick people.
Yeah, the yeses are what's most interesting, it feels like.
Right. So we need to pick performance metrics that are closer to, that evaluate the yes examples and the no examples a little bit more fairly. And so one way to do that is area under the curve of a receiver operating characteristic curve.
That's a mouthful.
Yeah, it really is. But the idea behind that curve is that to go from probabilities to yes and no, you have to pick some threshold. So, do you call everything above a 0.5 a yes? Do you call everything above 0.6 a yes?
That's a great point. Model delivers probabilities, not yeses or nos. Get that question a lot.
Yeah, and so the threshold, you can imagine, like, if you chose a really high threshold versus a really low threshold, you're going to get really different distributions of yeses and nos.
Yeah, exactly.
And so that's another reason accuracy is not a very good metric, because it implies that a threshold was chosen, but you don't know what it was.
Yeah, so you have to be flexible on threshold. And there's two ways you can be wrong with the model, right? You can over-predict or under-predict. And so at different levels of this threshold, you're sort of trading off. Are you wrong on one side or the other?
Yeah, that's a good point. So the benefit of the AUC is that it kind of it evaluates all the thresholds at once.
Wow.
And so any potential threshold goes into the performance metric, and that essentially kind of takes it out of the equation. You don't have to think about it anymore. Yeah. So that's one reason people really like it. And then the other thing that's really good about area under the curve is that it kind of, with a hand-wavy definition, it evaluates the positive cases and the negative cases with a little more, evenness. So even if you have imbalanced classes, it's going to do a better job at making sure that the model is evaluated on how many of the sick people it found, as well as how many of the healthy people did it pass.
That's a great point. Okay, so we like AUC more than accuracy for doing classification. Question, somebody mentioned confusion matrix in the chat. Great point. So you mentioned threshold. How does that tie in with confusion matrix?
Yeah, so the threshold is how you generate the confusion matrix. Once you pick the threshold, then you go through and you're going to count up all the false positives, the true positives, and then the false negatives and the true negatives, and you can build that confusion matrix.
So it's tied to one particular threshold, which may be a little bit limiting.
Yeah, but if you know the threshold, that's okay. Now, AUC comes from the confusion matrix over all thresholds, so that's why we kind of prefer it. But the confusion matrix is a good place to start.
Yeah, good place to start, you think. Interesting. So, the AUC covers all potential thresholds. So you wouldn't start with AUC, get an idea of your model performance, and then when you have a threshold, go to confusion matrix? I don't know if we've sussed this out. We haven't used confusion matrix a lot lately.
Yeah, we've been keeping it higher level, just looking at AUC and calling it quits there.
Yeah, but so let's say you have a doctor discussion where you're saying, hey, clinician A, here's how your model performed. You can either err on the side of false positives or false negatives. From there, you get a threshold, and so maybe once you have your threshold, a great way to display that is with the confusion matrix.
Yeah.
So thanks for bringing that up, Paul.
That's a good one. And then the other thing is this trade-off of performance or precision and recall. What's the difference?
Yeah, so that one's a hard thing to remember because there's some synonyms here. So is sensitivity the same thing as precision?
I can never remember.
Yeah, I have to use Wikipedia a lot for those.
But the gist of it is that AUC evaluates the positive cases and the negative cases, whereas precision recall evaluates the positive cases that were given as positive, and it evaluates the positive cases that the model said were positive.
So it focuses more on getting the yeses right.
Yeah, exactly.
The people that had cancer, did we say they were going to have it?
Exactly.
Okay.
So it kind of looks from both angles at the sick people. How well did the model do at finding the sick people?
Yeah.
So it's a harder metric to get good.
Yeah, it's less popular. So a lot of the literature you'll find in healthcare and other places focus on AUC, or what they sometimes call it a C statistic, I've seen.
Yeah.
So PR, or the precision recall curve, is a little bit more esoteric, or...
Well, so recall is the same as sensitivity. I might have that backwards, but assuming I have that right, precision is the same as positive predictive value, which is pretty common in healthcare.
Yeah. I guess the PR curve, or the area under the PR curve, is a little less.
Yeah, the area under the PR curve, that's more of a machine learning thing.
Yeah, but definitely helpful, and in healthcare AI.
Of course.
1.11 release.
Shameless plug.
Yeah. So this is good stuff, and this is classification. And where else do we go? What other things can we do with machine learning?
Oh yeah, that's a great question. So as I'm sure you know, you can also do regression. And so regression is, we're predicting a continuous output, and you're gonna have to compare, your continuous output versus the true continuous output. So all the stuff for classification we just talked about doesn't really apply, and that makes it a little harder. But it gives you other advantages too. So we can look at if we have a data set, we'll head over to an image, and if we look at a data set, you'll notice that a regression problem is typically a lot more visual. So you can kind of like plot all the data on, in a scatter plot, and then plot the line of best fit. And I've just shown a simple linear regression here. Maybe it's cost of a house versus square footage or something. But you get a nice idea of kind of what the spread of the data looks like and how you can evaluate that. And so, similar to accuracy, a lot of people start with the R-squared coefficient, and that's what comes out of Excel. And
Interesting, I know that.
yeah. And so one problem with the R-squared coefficient is that just like accuracy, you can get a really high R-squared for data that doesn't really fit a model. So, looking at these 4 examples, we have a few different cases where the data, a linear fit is just not a good fit to the data, but you're going to get a pretty high R-squared value because your data is close to that line, even though it's not a good fit.
Interesting. And it's pretty popular, maybe
Yeah,
too
it is.
popular.
So the other 2 options that are better are going to kind of focus on, they're going to focus on the residuals, which is the difference in the predicted outcome and the correct variable. And so that's a little closer to kind of looking at classification. In my mind, it's kind of more apples to apples, but with the assumption that the spread in the residuals is going to be a normal distribution because it's kind of a random process. The difference between the true data and the fit. You can do things like sum the absolute, take the absolute value of the difference and sum them all, and then divide by the number of points, and that's called mean absolute error.
And you want to take the absolute part of it because you don't want them all summing to 0 sort of thing.
Right. You don't want the negative ones and the positive ones to sum to 0, so you do the absolute. And if you're more concerned about outliers, you can use this thing called root mean squared error, which is where you square the residual for each point and then take the average of that and then the square root. And that kind of penalizes big outliers in your data more than just lots of small variations.
That's a great summary. And in terms of so if healthcare.ai gives you these metrics, by the way, so when you create a model, it tells you how well it did in terms of MAE or RMSE. One of the benefits with MAE is that it's in the same units. So you get this number, and it's like, well, what does this mean? Is this good? And so if you're predicting house price with mean absolute error, it will tell you the average error in terms of house price, which is kind of nice.
That is nice.
But if you're overly concerned or excited about making sure you're handling outliers well, then you would use RMSE, which is maybe slightly harder to interpret. But if you're using multiple algorithms like in healthcare.ai, then you can compare apples to apples, and it's not so difficult.
Yep. So the fact that all these algorithms or these metrics are in healthcare.ai makes me think that either the people who wrote the package are really good, or maybe they're paying us to be on this broadcast and talk about these.
Yeah, it lines it up. That's one of the benefits of healthcare.ai is it does it for you. And that was one of the annoying things is when I got started in machine learning, I had to recalculate these things and write functions myself for these different projects that we were taking on. And now everything's packaged up very nicely to make your life easier to say, okay, if you're doing regression, here's what's an appropriate metric, or for classification, here's AUC.
And we just have, one more point on monitoring or performance metrics, and that's kind of like, how do performance metrics change over time? Like, what could cause a performance metric to change? If you build a model and it's looking good, and then you put it in production, how do you make sure it's still good?
Yeah, so you can, I guess, most easily just manually check. We have something called the generate AUC function in healthcare.ai where you can go in and say, okay, well, I've gathered data for the last couple of months, seeing if people got an infection or not. And this will say, oh, here's your AUC. Here's how good your model did in production, which is quite nice because it could be quite different from when you're developing the model because the underlying data might have changed.
Yeah.
Health systems have really interesting data pipelines that aren't always static over time. Data leakage is one that we've come across. So that's a couple of big ones.
Yes. So if you can, watch that AUC over time and see if it's falling versus your where it was in development, maybe it's time to retrain the model, or maybe it's time to just leave the model alone.
Yeah. So you can decide, and it's super easy to retrain using the tools. Awesome rundown, Mike. Thanks so much. That's beautiful.
That's great.
So in the chat, if you have any questions, let us know. We actually want to do something new. We're going to bring out a poll question. And we're quite excited for this. And so what we'll do here is we'll direct you to pollev, POLLEV .com/healthcare.ai. So folks, if you wouldn't mind heading to pollev.com/healthcare.ai. I believe that's going up on the screen there. And we have a question. Says, where do you feel like you struggle most with machine learning? So we want to be able to help the community learn what people are struggling with, and that's the point of this poll. And A is finding an appropriate business question, B is data prep, C is feature engineering, and D is model evaluation. E is visualizing the predictions. So yeah, it's pollev.com/healthcare.ai. It's quite a handy little tool, pollev is, if you ever need a poll service.
Yeah, it's pretty good.
Okay, we have the responses coming in. It looks like finding an appropriate business question and feature engineering are actually the top two. Wow, actually finding an appropriate business question is pulling ahead. Interesting.
I think that's really interesting because like we were saying at the beginning with getting why is a Kaggle contest not as good as a project you've put together on GitHub, and that's because the Kaggle contest doesn't have the finding an appropriate business question part.
Yeah.
And that part's hard.
It is hard. You have to really know your business and know the tools, and we're here to help with that. We've been learning that ourselves here at Health Catalyst, and we talked a little bit about that in the webinar yesterday. Maybe we should have a whole broadcast just based around that. That might be helpful.
So how could we help the community with that idea? Maybe it would be finding appropriate use cases, use cases in healthcare. We've done broadcasts on that, but we'll have to think about how we can help people think about how to come up with a business question that's useful.
For sure, that's a good point. And if you want to drop any questions in the chat, in YouTube, or in the Slack channel, we can follow up a little more in-depthly over the coming days. But we definitely want to help you think about that because so many issues in healthcare, it's sometimes hard to know what to chew off first.
That's true.
Bite off. Okay, next question, 2 poll questions today, and then we'll finish up. So next poll question is, would you be interested in small machine learning challenges each week? So we've debated this a little bit. The idea is that we want to engage during the week. We want to help you make progress. So the idea would be to drop a small, tiny homework assignment in the Slack channel such that you have something that you're working on and asking us about in the same Slack channel, and then we can check in during the broadcast and see, okay, well, what do people struggle with? What's the proper route to accomplish this small task? So let's open this up. If you stay at pollev.com/healthcare.ai. And let's see the returns come in here.
Let those come in for a little while, and then
Yeah. So that, it's nice to watch things, but I feel like when you're doing a MOOC or when you're trying to learn something hands-on is the name of the game. And so we can have people follow us along here, but it might be helpful for you when you're not watching the video to have little snippets of things you're working on. So it looks like most people think that would be a good idea, so please, keep answering there if you haven't got to it yet. But we'll have to think on that.
Yeah, I think it certainly looks like the community is interested in that kind of thing. So maybe the best way for us to do it would be to kind of serve it up through the Slack channel and then spend a little time on the next broadcast discussing it once people have had time to kind of explore and do whatever it is.
Yeah.
Just
That's great.
Talking points.
And the idea would be we help you along in the Slack channel, and when you get stuck, you have a venue there where you can get help not only from us but other members of the healthcare community. So we'll follow up with that. So that's what we had for today. Any other items on the docket, I think?
Got nothing, Levi, except the weekly shameless plug to please subscribe and join the Slack channel, star our GitHub repos.
Oh,
and,
the GitHub repos, yeah.
You can send snacks and prizes to Levi and I at Health Catalyst if you really like it.
Yeah, we have a mailing address. Yeah. Thanks for joining, everybody. See you next week.
See you next week.
Thank you for joining us today. Remember to like, share, and subscribe, comment below, and click the links below to join our Slack channel and our Healthcare AI community.